All right, thanks, guys. This is the first lesson I've done with a website it's called Screencast-O-Matic. It lets me talk over the computer screen and it's recording, obviously, and for you guys to watch. So we're going to see how it goes. I'm going to try it out for the first time. I'm probably going to try and record about a 10 or 12-minute video, which you guys will be able to watch individually over and see if they can help you with any of your revision. Okay, so today we're going to be looking at what are the forces that form mountains, as I've got there. This is covered in chapter 4.3 of your textbook. So what did we look at last lesson, just quickly? We looked at 4.1, where are the world's mountains, okay? So we looked at and spoke about what are the features that are common to mountains. So let's look at some of those again. Mountains all have steep sides. They form a peak at the top called a summit. Some mountains located close together have steep valleys between them, known as gorges, and a group of mountains is called a range. Okay, so we looked at and learnt at where in Australia the Great Dividing Range is, for example. This is a map taken from 4.1, so our last lesson, that looks at all the different mountains and ranges in the world. Okay, so this first one here, so number 2 there, is the Alps. Number 1 is the Himalayas. We've circled there, so it's got Mount Kosciuszko, but in yellow, that is also Australia's Great Dividing Range. Number 4 is the Rocky Mountains in the States. And number 3 there is the Andes Mountains in South America. So I've just put that up there for a bit of revision. Hopefully that jogged your memory. Okay, let's have a look at forces that form mountains. Mountains just don't form overnight. There's a massive amount of forces that go into forming different types of mountains. The Earth is made up of many individual moving pieces called continental plates, okay? So I've just got to think of that as a bit of a jigsaw puzzle. So these plates form part of the Earth's crust, which is actually cracked. As I said, they form together to fit like a jigsaw puzzle. I've got to understand that these plates are constantly moving. However, the speed is very, very slow. They move around 15 centimeters per year. So let's have a look at what that actually looks like. So here's a map of the world. The blue lines, as you can see, they make up the plates, okay? So that's like our jigsaw puzzle, and that's what's actually moving. So we can see the arrows in grey show the direction that those plates are actually moving in. We look at our key in the bottom left-hand corner. Got the plate boundaries, as I said, the arrow is the movement. The little red triangles are volcanoes, and the yellow circles are hotspots, which we're going to learn a little bit later on. You can see Australia doesn't actually have any plates running through it or underneath it, okay? So we've got to remember that the plates are in the Earth's crust. What countries look like they have some plates running through it? We can see India has some plates going through it. Parts of the United States and some other countries as well. The moving of these plates is called continental drift. There's a new term for us, continental drift. So remember, okay, continental plates, continental drift is the movement of those plates. And they've got 3 different ways of moving. They're called convergent plates, divergent plates, lateral plate slippage, and transform boundary. We're going to have a look at those individually in a little bit more detail. All right, convergent plates or convergent movement. When 2 plates are colliding, these are called convergent plates. Okay, so think about 2 plates colliding. One of them has to be pushed up and one has to be pushed down. The area where these plates are colliding is called a convergent boundary. So just like your boundary on your football ground or your netball court, it's 2 different sides to a boundary. When these plates collide, it causes the crust to push upwards and can form mountains. Okay, so the Himalayas were formed this way. If we look at this picture here, we can see that the oceanic plate is coming in and actually going down because it's been met by another plate from the right-hand side, and it's been forced up to form, in this case, a volcano, but it can cause mountains as well, as we just learned that the Himalayas were formed that way. Okay, divergent plates or divergent movements. When two plates are moving apart, these are called divergent plates, all right? So they're moving apart. Convergent plates were colliding, divergent are pulling apart. The area where these plates are pulling away from each other is called a divergent boundary. Okay, again, using the boundary. As divergent plates separate, magma can rise up in the opening, forming new land. So magma is actually what we call lava. So lava is what comes out of a volcano. Magma is the lava, but before it's come out of a volcano. So underwater volcanoes and islands are formed this way. So divergent plates pulling apart. So there's a gap there. All right, so think about it. If you're pulling plates apart, whatever's underneath has to come up. And that's how, okay, underwater volcanoes and islands, so magma's pushing the new crust upwards. It's going to poke up into whatever it is. So it might be above the ocean surface or form a volcano. Okay, and our third type of continental movement is the lateral plate slippage or transform boundaries. When two plates are sliding against each other, this is called lateral plate slippage. Okay, so they're not pulling away from each other, they're not pushing into each other, they're actually sliding. Where this area occurs is called a transform boundary. And these cause and result in what we call faults, as we can see in the picture here. So they're sliding against each other. This is a really nice picture that sums it all up. Okay, so we've got divergent movement where they're pulling apart, convergent movement where they're pushing together, and transform, okay, or lateral plate slippage, all right, transform boundaries where they're sliding against each other. I'd like to show you now a video, okay, it goes for about 4 or 5 minutes. Just hang fire with me while I get it up. Okay, here it is. This is going to explain it really, really well, okay, so it's going to go over again what we've just spoken about.
To understand more about plate tectonics and continental drift, we have to look deep inside the Earth. The Earth's interior consists of several different layers. The inner core, which is believed to be solid iron and which is very hot. The outer core, which is believed to consist of rocky material so hot and under such great pressure that it is in a liquid state. The mantle, which is not as hot as the outer core and not as liquid. The mantle's outermost portion is solid. This is the solid outer portion of the mantle. Above this is the outermost layer of the Earth, the crust. Together, the crust and solid outer portion of the mantle form the Earth's outer shell. They are referred to as the lithosphere. It's not always easy to see the Earth's crust. It's covered by vegetation and the oceans. But if you could drain the Earth's oceans and strip away our planet's vegetation, the Earth might look something like this. Now we can see the Earth's hard outer shell. And if you look closely, you can also see the shell is cracked. The red glowing lines mark the places where the Earth's shell is cracked into tectonic plates. Each plate carries a continent or an ocean basin, or sometimes both. The plates are moving at an average rate of 1 to 2 inches a year in a variety of directions, carrying continents and ocean basins with them. Here's why the plates are moving. Scientists believe material in the mantle is circulating much as it is doing here. The movement may be caused by heat within the mantle. You can get an idea of how heat can cause a circulating movement by watching rice as it boils. What you see happening within this beaker is similar to what's happening within the Earth's mantle. As mantle material moves, perhaps only inches a year, it causes the plates above it to move as well. In some places, plates are moving in opposite directions. they are moving apart. The area where two plates are moving apart is called a divergent boundary. In other places, plates are colliding. The area where two plates are colliding is called a convergent boundary. And in other places, plates slide past each other. This area is called a transform boundary. This is a cross-section of a divergent boundary, the mid-ocean ridge located beneath the Atlantic Ocean. The North American plate is on the left, and the Eurasian plate is on the right. Scientists believe that as the plates move apart, mantle material called magma rises to fill the gap. Magma is the name we give lava before it erupts from volcanoes, as it is doing here. The magma cools and hardens on the ocean floor, adding new crust to old. And as the seafloor spreads, North America moves farther away from Asia. The highlighted area on this globe shows where magma is surfacing between plate boundaries beneath the oceans, creating a mid-ocean ridge that circles the Earth. The ocean floor spreads in one direction on one side of the ridge, and in the opposite direction on the other. The mid-ocean ridge is where plate material is created. And this is where plate material is destroyed, a convergent boundary. In this cross-section, the plate on the right is carrying an ocean basin and is moving in this direction. The plate on the left is carrying a continent and is moving in the opposite direction. The plate carrying the ocean basin is heavier and is diving beneath the plate carrying the continent. The leading edge of the diving plate is consumed back into the Earth's mantle. When one plate dives beneath another, it is called subduction, and the area where it occurs is called a subduction zone. Subduction may resemble what is happening on this lava lake, as sections of hardened crust dive beneath other sections. The highlighted areas on this globe mark convergent boundaries. Subduction is occurring at most of them. These are the areas where plate material is destroyed. Here again are divergent boundaries, where plate material is being created. Again, most of them are beneath the oceans, creating a mid-ocean ridge that circles the globe.
Okay. So